So this is the diagram I make based on my discover based on my experiment with the generator, and this diagram is very very accurate because when the north pole of the armature is approaching a coil will try to resist it because every rotation is a one-way rotation. Either it turn clockwise or it turn anti-clockwise. Every generator rotates. There are some generator that rotate clockwise, and there are some generator that rotate anti-clockwise, but it's the same direction. So it can rotate clockwise immediately and rotate anti-clockwise immediately. No, it has to be rotated in one direction. So from this arrow, we understand that the armature is spinning clockwise, rotating clockwise around this stator here. The stator is static; it is not rotating. So what happened when you load it? What happened when you load the generator? So when you load the generator, which is you can see the load sign here. When you load the generator, you have already closed the circuit. So you have already closed the circuit. Depending on the load the load capacity, you will find that rotating the shaft of the generator will be so hard if you're using hands, or if you're using a motor, or if you're using a engine to drive it. If you're using the engine, you will experience the engine will be taking more fuel to compensate. And if you're using a motor, you will find that the motor will be taking more amp, more current to compensate. And if you're using a hand to spin it, you will find out that the shaft will be more hard. You will be you will be forcing yourself to rotate it. But immediately you remove this load, the armature will be free. The shaft will be free to rotate again. So what happened? There is a force that operates. There is a force that operates because when this rotor is approaching the coil, when the rotor is approaching this coil, this rotor is not, and this rotor here is a constant power, which is it is a DC. It is a DC, so it is constant. But the field coil here is AC, so it fluctuates. Now, when the north pole is coming close to this coil automatically form north to resist it. You know, there is a difference between back EMF and EMF. This coil induce EMF. This coil interact with this armature, interact with this coil and generate electricity. But there is the opposite force. Normally, you can describe back EMF in a motor, but the same thing that happen in the motor also happen in a generator. So when this lotto here is approaching the coil oppose. The coil oppose. The opposition is a force, but that doesn't mean that there will be no output. There will be output, but in terms of the mechanical driving, you'll be experiencing a lot of force. And you know that like pole doesn't attract, but unlike pole attract. Not North and North doesn't attract, but South doesn't attract, but North and South attract, and South and North attract. So unlike pole attract, but like pole doesn't attract. North doesn't attract, South doesn't attract. So when this uh, uh, lotto here is coming close to here, this coil will form knot, which number one is it will try to suppress the magnetic force. Yeah, I mean the magnetic strength of this uh, armature here. It will try to reduce the magnetic force, the magnetic strength, because every magnetism has its strength. Like we have a N35, N42, N50, N52 by the strength. So when this appear, it will try to reduce the magnetic strength of this uh, uh, armature here. That is number one. Two, this armature here will be having mechanical. It will require high mechanical. You will need to put more mechanical power to drive it because not and not cannot attract. So down here, the same thing operates. This armature here, this field coil here will form south to oppose the south, to oppose the movement, to reverse it. Remember, the rotation is spinning in one direction. It will form this south to oppose it. So now this is a remember this is a diagram. So this is a second diagram, which is the B diagram. So what happened? When this lotto here has managed to escape from the coil, field coil, which is stator, the stator here will collapse and form south. Remember the first diagram, it is not. So assuming if if this polarity change here is constant, remember when the coil now manage to escape, this knot will help push this rotor out. It will help act like a kinetic energy, but due to its change, it reverse immediately. So assuming if this change here is constant, you remember that when you put more power, mechanical power to drive this armature leash here, when it is now leaving here, it will now require, it will act like a kinetic energy and push it away. But it still reverse. It reverse, and when it reverse, it try to attract it back again. Try to attract it back again. So when this lotto here, the armature here has managed to escape from the field coil, the coil collapsed and forms out, and which it tried to attract it back again. And this one we form knot to try to attract the armature again. So that's what happened. That's what happened. When this armature managed to leave the coil will form south to attract it back, and this one will form the coil will form north to attract it back, and this coil will form south to attract this uh rotor here. This is two. This one with is a four break in the generator. So now this is the third diagram here. You can see now the circuit is open. The circuit is open. So when you are rotating the armature here, it is free because there is no opposing. The circuit is not closed. It is open circuit. So the armature here will be rotating freely because there is no opposing force. The field coil here is not south, is not north, it is empty. It is just neutral. So the lotto here will be rotating it freely, but immediately you load it, there will be a position, like display in the first diagram and second diagram. But this is the third diagram. So there is no any load. So the armature is expressing no force. The magnetic strength is the same. The mechanical force, there's no increase, there's no reduce because there's no any opposing force. So the output is just normal. But immediately you close it, immediately you put load, or immediately you try to short circuit the output, this two terminal, this output terminal, immediately you try to short circuit it, the Lenz effect will come on board. The Lenz effect will appear, which will try to resist the motion, the movement of this coil, and it will make it in the opposite direction, that south doesn't attract, north doesn't attract. So that is exactly displayed in the first diagram and second diagram. It is exactly displayed in the first diagram and second diagram how the Lenz effect work in every generator we use. How the Lenz effect work in every generator we use, we will make use of.